Hello, people of Hashi Talks. Welcome to this presentation on GitOps, one repo to rule them all. Today, we'll be using a single source of truth for creating, managing, and maintaining all of your infrastructure and application systems. This is a really cool topic that I'm excited to talk about. Why is this so cool? Well, we're going to cover some declarative full stack information, some deployment pipelines, and some drift management methodologies from a single GitHub repository. We're going to talk about some context of what GitOps is with this scenario. We're going to do some comparing and contrasting of different IT operations models, some of the tools involved with GitOps, give a little demo context, and then we're going to hop into a demo and tie it all together and see it in action. So let's get started. Who am I? My name is Eddie Rowe. I'm excited to be here. I am the lead Consul education engineer here at HashiCorp. What do we do as education engineers? We essentially create content like this for the public to consume, practitioners to ingest and use and help build models for their productions or other uses out in the world. We do stuff like this. We do technical writing. We do the tutorials. We have a lot of content out there with the goal of serving you. You can also find me at this LinkedIn right here. I'll put this at the end as well. If you have any questions throughout this whole presentation, feel free to send them my way or put them in YouTube chat down below. So I really like Lord of the Rings, and you're probably going to be able to tell by the end of this presentation. Let's go ahead and check out our overview. We are going to navigate this subject with this map right here. The lands are treacherous as they are laden with terminology like zero trust, infrastructure as code, and feedback loops. So we're going to use this map to get us through these treacherous lands. Every story has a beginning, so let's start there. To compare these ops models, we're going to start by defining what they have in common, and then talk about the differences between ops, DevOps, and GitOps. So these are some of the general actions in the form of verbs right here that organizations perform to deliver IT services to their service consumers, be that machine or human or dwarf. You've probably seen these verbs before in that infinity symbol CI/CD diagram. If you've Googled that, it's very common. The difference between traditional ops versus DevOps versus the GitOps models is in the how and the who of these verbs right here. So how do different organizations perform the actions necessary to implement, manage, and deliver their IT services to service consumers? And that's primarily what's going to make the difference between these models. So let's dive in. And let's start by taking a look at the traditional ops model. This is the who and the how of the traditional ops model. And big asterisk before we dive into some of the details. Every organization is different. And this is a generalization for the purpose of doing some comparing and contrasting between these models. So with that said, in order to perform their roles, traditional ops environments may have roles such as project managers or managers, developers, QA, and operations and support, who use variants of the tools of the icons that we've listed here. Each role perform their duties with their tools and track the details in change management software, and they may track it in a wiki as well. In fact, these may be the main shared connection points between these teams, leading to individual teams working mostly in silos or specialized units. So if you've ever been in a place where a change management ticket was held onto it for a while by a networking team before one of the team members implemented that change, you may know this style of place and be familiar with this kind of workflow. Some of them are certain government entities or private organizations that operate in a legacy model. Now, the challenges of this kind of environment is a big one here is imperative state. I want to touch on that for a second. Imperative state is when you say how you get what you want, maybe in the form of a wiki with a lot of screenshots where you click through to get the desired income, as opposed to a declarative state. And a declarative state is what you say when you say what you want exactly. And this may be in the form of a configuration file that defines all the attributes to achieve the desired outcome. Now, some more traditional ops challenges this model is it could be overly complex with a lot of different systems, difficult to audit. A big one is the plan to release cycles take a long time, perhaps for reasons like the change management example we brought up in the previous slide. These models with imperative style operations are subject to human error and delays, and they require duplicate effort across various systems. Now, the DevOps model addresses many of the traditional ops model challenges by streamlining their roles and tools. This increase in collaboration also increases work efficiency and speeds up time to release. So in order to perform these duties, the DevOps environments may utilize roles like release managers, developers, automation architects, and operations and support, who may use variations of the tools listed here. What you may notice in this type of environment are more connected aspects of the CI/CD process across roles, as well as more shared tooling between these roles. And if you've ever worked somewhere where you've had to upgrade a Splunk ecosystem or plan configuration management update or server patching updates across your fleet, you may know this kind of place. Many modern organizations that work in this kind of model. Now, the challenges of this DevOps environment is that there's a lot of complexity to it. There's many distributed systems and a lot of tools. Each may require a certain update cycle or maintenance that's unique to those tools. The environment can also be difficult to audit. The maintenance of individual systems can be cumbersome, and they may have an imperative state or a mixed state between imperative and declarative models here. And there's still that very noticeable split between dev, sec, and ops. More touch points, but there is room for improvement there. This brings us to GitOps, the who and the how of this. Depending on the size and design of the organization, GitOps-style environments may have roles like release managers or project managers, developers, and SREs in support. A key differentiator that we'll see here is the utilization of GitHub as the primary connection point for facilitating the plan to release cycle. While each role still has its own processes, technologies, and duties, each of their respective orgs may utilize individual repositories or components of a repository as a single source of truth for the respective systems. The GitOps model is common amongst cloud-native organizations as they work by utilizing GitHub integrations with tools like Kubernetes, Terraform, and other CI/CD supporting systems like Argo and Flux. Due to the various integrations and automation, deployments become more consistent and require less manual work. So this may sound like the ideal state, but the life of one dwelling in Middle Earth is not free from stress and worry. These are some of the challenges that the GitOps methodology faces. Setup takes careful time and planning. Moving from the imperative model to a declarative model takes heavy consideration. And the more legacy systems and services that an organization or one has to move over to this model, it does take time and will increase time the more you have. The required technologies in use here require training in a different mindset. If anyone knows, coming from the VM world to the Kubernetes world, it is an adaptation and can feel cumbersome to begin with. The automation pipelines are still subject to human error, just like anything is. The pipelines here are just as good as the implementation of the pipelines. So with this being said, why is the effort even worth it? Well, we're going to show you. Understanding these benefits and efficiencies is what drives our customers to strive for this type of model for creating, managing, and maintaining their IT systems. A big one here, one workflow on one code base means faster iterative changes. It's also much simpler to audit in this kind of environment. It's all in GitHub and in PRs. The declarative state improves stability and resilience. So what you see is what you get. And then the rollbacks are easy too. So there's a built-in form of disaster recovery and planning. It's in many cases as simple as reverting a PR to revert to your previous system state. So in the next section, we're going to dive into how these benefits can be realized. But the main point of these comparisons is to show how GitOps is an evolutionary step in CI/CD, primarily due to its resource management capabilities and feedback loops. And just like Gandalf the White is still Gandalf the Grey at the core, GitOps is still a CI/CD methodology at the core, just with way more skills and powers. Okay, so hopefully we've given some more insight into how GitOps differs and resembles other IT operations models. The zoomed out view that we just covered helps understand the what and the why of GitOps. Now let's dive deeper into the how of GitOps. And getting started with a net new GitOps workflow is easy and almost free. In this example that we'll cover, the only cost for the core features involved here is a domain name. So let's talk about the main elements of how GitOps works. It's essentially a 3-step workflow. You code something into a GitHub repository. The integrated tools perform CI/CD and state sync, and then the deployment occurs as a result of that CI/CD and state sync. So as far as the workflow goes, there's many similarities with the DevOps model, but a few key distinguishing differences. The CI/CD mechanism takes declarative philosophy very seriously for the state sync. Once you go declarative, you never go back once you realize those efficiencies. It's one repo for everything. So this is your deployments and updates, your audit logging, your rollbacks, your infrastructure, your apps, and your security and compliance configurations in one location. And then another key differentiator here is these integrations like Flux and Terraform Cloud that perform that CI/CD and state sync and make it so according to your repo. GitOps workflows really shine in the cloud-native microservices and Kubernetes world, but they can also be utilized for on-premise and hybrid systems just as easily. I think the Tripwire CTO, his name is Gene Kim, describes the subtle difference between DevOps and GitOps really well in his book, The Phoenix Project. He says the second way is about creating right-to-left feedback loops. And in many cases, those right-to-left feedback loops involve the utilization of Terraform Cloud, drift detection, and Flux or Argo state sync. It's your actual deployment continuously being compared to your repo's source code, asking, is this how it should be? Is this how it should be? Is this how it should be? And then ensuring that it's exactly in that state. Coupling this workflow that we see here on the slides with storing all the code that describes our system in a versioned manner, applying them automatically through that well-defined process, and then finally using a self-healing system is what we call GitOps. So let's cover the elements of a simple GitOps workflow in a little more detail here. First bit that we mentioned on the previous slide, coding. So the process that we're going to do in our example 2 is GitHub is the center point of this universe and interaction point for all humans. You create a pull request. You or someone else may review the pull request, and then the pull request gets merged. As a result of that merging, the CI/CD and state sync take effect here. In our case, we're going to use Flux and Terraform Cloud, and these are responding to those state changes in the GitHub code repository that you just made changes to. Finally, our deployment occurs. As a result of that, infrastructure resources are created as a result of this workflow. So 1, 2, 3. Now that you've seen the what, the why, and the how of GitOps, let's dive into a demo to see it in action. So let's deploy something. I want to level up my Zero Trust security profile with identity-based access. So I want to deploy Vault in my environment and start setting up Vault. And again, this is how we're going to do it. We're going to create a pull request, review the changes, and merge that request. So let's check it out. All right, so we have hopped on over to the pull request here inside of GitHub. And let's take a look at some of the changes that we're proposing in this pull request. First, we just have a small Vault addition to the customization file for configuration management. The real meat of this is in this Helm release file. And it has all the contents that you would normally have with a Vault Helm release file within here, with the caveat of some of these Flux system and Flux attributes here. And this is what enables Flux to manage the Helm release, both the initial creation and the management of it, and updating throughout its lifecycle. The next file that we have is another configuration management file within that same directory. And then finally, this bit right here is a service definition file that in this repository, what it does is any services that are listed here, when Terraform Cloud looks through this and sees any changes, it's going to ensure that everything in this service list is going to have an associated DNS resource created for it in Cloudflare, as well as the Cloudflare Zero Trust resources. Okay, so this looks good to me. I'm going to go ahead and merge this pull request to our main branch. Good job, me, for writing this pull request. All right, back in our presentation. So as a quick reminder, these are the steps that we just performed. We created the PR, reviewed it, and merged it. Now, what happens as a result? So it's time to open a ticket to the operations team to deploy it, right? And then to the networking team for the SSL certs ports. Now, this is where the GitOps auto magic kicks in. Since Flux is watching your GitHub repository, it will deploy the Vault service and other resources from the annotations defined in the Helm chart, in this case, an SSL cert and an ingress route, into your Kubernetes cluster. Terraform Cloud is also continuously watching your repository and will deploy Cloudflare DNS resources and Zero Trust resources for your Vault service. As an added bonus, Renovate bot continuously monitors your Vault Helm chart for updates and will automatically generate PRs with updated things like images or Helm chart versions for you to review and merge if you so desire. This drastically speeds up and simplifies updating across your service. And with test dev cluster instances, you can easily test these new versions out before implementing the changes into your prod cluster. And this is just a simple example to illustrate the core GitOps workflow. This is all highly customizable and extendable in any direction, depending on your intentions and or your requirements. For example, you could add annotations or additional GitHub actions to integrate Vault into your own observability suite or testing suite. It's really all up to you how you choose to design your pipeline and which systems you'd like to incorporate. So let's check our work. Did our workflow that we just performed, that PR merge, give us the intended result? So let's check it in 3 spots. We're going to check it on the Kubernetes cluster itself in the terminal, in Terraform Cloud in the browser, and then finally, we're going to check if our new Vault service is publicly available in the browser as well. As a bonus, we're going to check out our repos pull request tab in GitHub to see briefly how Renovate bot works and some of the PRs that it generates for updates. And just a cool part of using this methodology, let's say you merge any of the PRs, for instance, like Vault, we just merged that one. It doesn't work as intended, it causes problems. Totally fine. Revert your PR change and the deployment goes away without any estranged resources or partial cleanups is a very important part of that. So let's hop into the second part of our demo and check our work. All right, the first place that I want to check it is the terminal. This is the previous run of kubectl git pods right here. You can see that Vault is not present. So let's give it a run now. All right, after merging our PR, you can see that Vault pods have been up for about 2 minutes. You may notice the 0 out of 1 state. This is normal for Vault at this point right here. Vault is a security program and it starts up relatively secure, as you may expect. So this requires a little bit of bootstrapping before it'll say 1 out of 1, but it'll still be publicly accessible. So we'll still be able to run our tests here. Okay, so we've merged our PR. Let's hop over to Terraform Cloud and see what Terraform Cloud looks like. I'm going to refresh the page to make sure we have the latest and greatest. And here we can see the latest run that's triggered here. You can see that Terraform Cloud responded to our PR change, or our merge from this PR, the Vault service PR, to our main branch. And it already applied it. You could also set up Terraform Cloud to just run the plan operation here, which will stage the changes, say what changes to be made, if you'd like to add a manual checking step here. But for the sake of automation, because we trust the thoroughness of the PR that went through when it was merged, we have it automatically sent through and deploy the Terraform resources. Now, what did it deploy? If you see the plus signs over here, you can see that DNS record was deployed to Cloudflare, a special administrator policy for Vault, and then some more Zero Trust resources for Vault were all created in Cloudflare. And we didn't have to go log into Cloudflare or click anything. All right, now let's see if this thing is actually accessible. We have all the resources in the cluster and outside of the cluster. Let's go to Vault, and then my domain name is openenergyproject.org. Feel free to go there too. See if you can hack into it. No, just don't do that, please. Although I doubt you can get in. So yeah, here we are. We are seeing Vault publicly. Right here, all the operation worked. We have a full public deployment that's working totally fine. We're able to access our Kubernetes cluster resources from those Cloudflare DNS entries. So awesome. All right. And so there it is. We checked all our work. Everything worked as expected. And that is a GitOps workflow. So alas, we have reached the end of our journey. My hope is that you can take something from this to benefit yourself, your coworkers, or your organization. As the technology landscape continues to change, it's always useful to try out something new to see what works for you. There's no perfect prescription for a system out there, no perfect recipe. What works best for you is unique to your environment, your limitations, your constraints, and your intentions. An important caveat that I'd like to call out is this was a home lab-based workflow. There are a lot of enterprise considerations. Big one is test dev branches and not committing directly to main and checking deployments. So definitely consider that in your practices. As Tolkien said, elves seldom give unguarded advice, for advice is a dangerous gift. Even from the wise to the wise, all courses may run ill. So yeah, there's no perfect prescription for a system. All right, that is GitOps, one repo to rule them all. Thank you all so much for your time and attention. I had a great time doing this. Put up my email address and my LinkedIn here, as well as the repository if you'd like to try this out. If you have any questions, please feel free to ask them in chat as well, or send me any kind of communication, any of these mediums here. Hope you have a great rest of your day. Enjoy the rest of HashiTalks, and see you next time.